Hi. Alright. So here we are again. Now I'm going to tell you how to obtain the hydrogen ion concentration and the hydroxide ion concentration when you have the value of the pH. So in this case we have this to calculate the hydrogen ion concentration and the hydroxide ion concentration from a substance that has a pH of 5.5. Alright. So the first step of this uh, is to use a function that is called anti-logarithm. Okay. So this function of antilog or antilogarithm, to use it, you have to press the bottom shift and the bottom log from your calculator, and it will do something like power of 10. Okay, that's pretty much of it. Remember the what is the logarithm function? So this is like the opposite. So we're going to obtain a power of 10, and the formula to get it is just like this. Okay, the concentration of hydrogen ion, it will be equal to the anti-logarithm of the value of the negative pH. All right, there is. All right, so everything we have to do is to press shift log and then the sign of the negative and then the value of the pH that we have, that in this case is 5.5. Right, so once we do that, we will obtain the result just like that. So this is kind of easy, and the result of this is 3.16 times 10 at the power of negative 6 molar. Alright, so this is to obtain the hydrogen ion concentration because we have the pH as the initial data. Now, to obtain the other ion concentration, we have two options. Okay, the first option I want to share with you is to use the formula in which we involve the Kw. Okay, remember that the Kw is like the constant for the ionization of water. Okay, so we will use that value of Kw divided by the hydrogen ion concentration, and we know that the Kw is always 1 times 10 at the power negative 14. We're going to divide it by the hydrogen ion concentration we have right now, that is 3.16 times 10 to the power negative 6, and that will give us the result. Okay, so once we do it, the result is 3.16 times 10 at the power of negative 7. No, sorry, negative 9. Alright, so I'm going to write it again. There it is, negative 9. Alright, so this is like the first option I want to share with you, but there is another option, okay, that maybe for some of you could be easier, or maybe, I don't know, maybe you can think that it has more steps. Anyway, I'm going to write just here. Just let me check my screen right now. So this is the first step, this is the second step. Now, alright, here, there it is. So this is gonna be like the plan B, okay, that I want to share with you. So instead of having using the KW, we're going to use the other rule that says that the pOH plus the pH is 14, so we can obtain pOH when we have the subtraction of 14 minus the pH. So for this problem is 14 minus 5.5, and that's a pOH value. Okay, so the pOH for this is 8.5. All right, so now we do the same procedure as we did for the hydrogen ion concentration, but instead of hydrogen, now we have instead of having the pH, now we have the pOH. So that will give us the concentration of hydroxide. So is the anti-logarithm of the negative pOH. Okay, so that's everything we have to do. We're going to use the anti-logarithm, that's like the power of 10 again, okay, of the negative value of the pOH, that is 8.5 there, and we'll get the result. Okay, so the result is 3.16 times 10 at the power negative 9. So you can see right now that we have just like the same value in both, with using both of the methods. Okay, so the one that you think that is like easier for you, just use it. Okay, it doesn't matter if you use one or the other one, you will get to the same result. All right, so that's all for this video, guys. So maybe I will upload another video later. Goodbye.